It is now time to put everything we learn into practice. For this exercise, you will be assuming the role of a designer and engineer to resolve a specific problem. Today, you will be designing the front wing of an F1 car. As you may know, the tires in an F1 car are fully exposed to the air, and that creates a lot of drag. The front wing of the car can be used to provide downforce and at the same time deflect the incoming airflow around the wheel to reduce the drag. As in the real world, for this challenge you will follow regulations that limit the size and position of the wing, as shown here. For your convenience, we have provided a regulation volume that you can easily use to visualize the limits of your design. Your objective is to reduce drag without losing too much downforce, so the car can maintain high cornering speed. You can use one of the three predefined models located in the example geometry component, or create a new design from the front wing on your own. Feel free to move and modify any of the existing designs. There is no limit to the number of wings you can use. The wings must be connected to the end plate and cannot protrude outside the regulation volume. The minimum thickness you can use for your wings is 25 mm. A trick to easily compare the different geometries using the monitors is to select all the geometries when setting the monitors up. The monitor will automatically update based on which parts are active for the simulation. Let's now take a look at the tools you can use to create new geometry. To create a new wing section, the first thing we should do is go to the model tree and right-click Design Challenge at the top and select New Component. Notice that the colors on the other components have been dimmed. This is because our new component is now the active component. All this means that the changes that we make are going to be applied only within that component. Use the keyboard to give the new component a name. In this case, we'll call it front wing, and press enter. Now you can begin creating the new geometry. We can rotate the model and select this face at the end plate. Then press the letter V on the keyboard to go to the plan view. With the face still selected, we can go to the Design tab and select the Spline Tool from the Sketch section. The Spline Tool will allow us to create a smooth sketch curve. Click anywhere on the plate to begin. Then move your mouse and place a few more points. Notice that the curve is passing smoothly through each of those points. For the last point, double-click to complete the placement. The easiest way to guarantee that the profile is at least 25 mm thick is to use the Offset Curve tool. Go to the Design tab and in the Sketch section, click Offset Curve. Select the curve you just sketched and move the mouse either up or down. Then type in a value. For this challenge, we'll use 25 mm. Then press enter. To complete the profile of the wing, sketch two lines, one at each end, to close the set of curves. We'll sketch a line at the front and then pan over to the back and create that line. Now zoom out. Start the Pull tool from the Design tab or by pressing the letter P on the keyboard and select the newly created profile. Click and drag to extend this some distance past the wheel. If you need to check if you are within the bounds of the regulation volume, go to the model tree and enable the display of the regulation volume. If you happen to be extended past the bounds, go to the Design tab and start the Combine tool. This will allow you to cut the wing using the geometry of the regulation volume. Select the wing as the target object, then click the volume as the cutter object. Using your mouse, click on the part that protrudes past the regulation volume to remove it. Go back to the model tree and hide the regulation volume. To make this wing segment as aerodynamic as possible, let's round the faces at the front and the back. Select both edges on the front face, then start the pull tool. Click and drag in the same direction as the arrow, and then reverse the drag direction. This will create a full round. Repeat this process on the back of the model once again. Clicking and dragging in the same direction just a bit and then reversing the direction. Now you're ready to test this out in simulation. If you want to make adjustment, you can select the component from the model tree and use the move command. The best way to do this is from the side view, where you can move the wing up or down, left and right, and you can also rotate it. Don't forget that you can reposition the move tool to select a new location as your reference. For example, if we reposition the move tool and then use the rotation handle, the axis of rotation has now changed. You can also use the move tool to change the orientation of the curves while sketching. Now you're ready to design your front wing. Good luck!